Hi, in this video we are going to take the data that we have just written into our Quadrant database and we are going to implement a very simple RAG pipeline on top of it. So for this initial implementation, before we actually move that into our backend code, I will be creating a new notebook right here. So new file 03 RAG pipeline. Okay, so for dependencies, we don't need too many. We only need OpenAI client and Quadrant client. Quadrant client for data retrieval and OpenAI client for generation and embedding. Let's select the kernel so that we don't forget it. So the first thing that we want is the embedding function. So the embedding function we already had in the previous notebook, and we can just borrow it from here. So let's just copy this and keep it here. So remember, we need the same embedding function that we have used to write data to the vector database. We need to reuse the same embedding function for retrieval purposes. Now, just remember that RAG pipeline consists, simple, naive RAG pipeline consists of a few steps. So first, we take the user's query, we embed it using the same embedding model which was used to actually populate the vector database. Then we are using that embedding to run cosine similarity, in our case, search on top of a vector database to retrieve the most similar vectors. Then we are taking the text that represents those vectors and we pass it as a context to the large language model to try and answer our question, our initial question. So we have retrieval and generation stages of the pipeline. So first, we are going to define the retrieval function. And for retrieval, we already have most of it. So if we would implement this Quadrant client as we did before, we can get inspired by the retrieval process that we have done at the very end of the previous notebook. So we have this retrieve data function. We can copy it and paste it here. Now let's make it a bit more advanced, just a little bit, nothing really complex. So first thing, I want to pass a Quadrant client around here, so that this Quadrant client is actually taken as a variable of a function. So this remains, but I want a little bit more data retrieved. Limit k, which is fine. So first of all, I want retrieved context IDs. I initiate it as an empty list. Then I want the retrieved context itself. Then I want similarity scores. And I also want retrieved context ratings. Retrieved context ratings. which is also initialized as an empty string. And now for all of the results, because results is a list of points, returned points, and those returned points have payload returned with them as well. So what I'm gonna do, just for simplicity case, I will do this. So I'm looping through the result, and I'm appending each of the list with corresponding values that I am interested in. So the retrieved context ID is the parent ascend, which is the product ID of our item. Retrieved context is the description itself, so the text. Context ratings is the average rating, and similarity scores are taken straight from the result. And I want to also return all of this as well. Okay, so this is my retrieve data function. Why is this complaining? Yes, comma. Okay, so this is my function for retrieval. I will be retrieving a little bit more metadata than just the text itself. That's why I wanted to expand the function a bit. And now let's try out how it actually works. So retrieved context equals to retrieve data. It takes in a question, and my question could be something like, what kind of earphones can I get? Kind of earphones can I get? And let's pass the quadrant client. And let's say k equals to 10. Okay, so this time around it was really fast, and let's see what we have retrieved. Okay, so now we have our result, and we have a list of product IDs retrieved, the list of actual descriptions retrieved for each of these items, and the list of ratings, average ratings, and then similarity scores as well. So most of this is just metadata. For example, similarity scores are not that relevant apart from really inspecting if nothing unexpected is happening. For example, all of the similarity scores being extremely low, which could signal that nothing really important has been retrieved, which is not good. But in general, just a piece of metadata, which is not always that useful. So the next thing that I want to do is format this data so that it is useful for an LLM. I'm gonna go ahead and copy paste a function which does the formatting, and we'll look into it, what it actually does. So formatted context, eventually we will be passing a string to a context of LLM via a prompt. So we need a string constructed out of these items. So first of all, I am looping through all of the retrieved items, and I am formatting them into a markdown list, which has the ID, the rating, and the description as a list item. Let's see how it looks like. So preprocessed context equals to process context, and we are passing this retrieved context right here. So preprocessed context is now framed. Where is the autocomplete when really needed? So preprocessed context is now a list of 10 items. Each of the list item is ID, it has an ID, a rating, and the description. So the most useful data is the actual description, but if we include this additional metadata, then we can ask a little bit more complex questions, like what kind of earphones, let's say we have, and I'm only interested in the ones that have ratings above, let's say 4.5 or something similar. Okay, so we have a piece of pre-processed context, which we'll be using to inject into a prompt. So the next piece is we're actually creating a prompt function. I'll just call it build prompt and copy paste what I have already implemented. But basically it takes in this pre-processed context, it takes in a user question, and it then formats the prompt, basically renders the prompt template. And the prompt template itself is, you are a shopping assistant that can answer questions about the products in stock. You will be given a question and a list of context. And your instructions is you need to answer the question based on the provided context only. Never use word context and refer to it as a available products. So when I worked with GPT-4o Mini, I noticed that if we don't have this specific instruction right here, the LLM would call or refer to the items as the context. And so that's why I added this additional instruction right here. And then we are passing the context, which is the processed context, and the question, which is the question. Now, this is just a function to create and render the prompt. Now we can actually go ahead and test how it works. So prompt equals to build prompt. And we are going to pass the pre-processed context, and a question. Let's say, what kind of earphones can I get? Now let's see how the prompt looks like. Print prompt. Yeah, so we have a properly rendered prompt where the context has been ingested as a list, and the question is also ingested at the very end of the prompt. So the next thing, what we want to do is actually go ahead and use the prompt and generate an answer. So we now have a retrieval step finished. We have a prompt rendering step finished. The next step is generating the actual answer. So I'll call this section generate answer function. And it is a simple generation function which will take in a prompt, use GPT-5 Nano with reasoning effort set to minimal, and we'll simply run this prompt and return the answer. Now, the prompt is this: what kind of earphones can I get? But this is not, let me think a bit. Was this about earphones actually? Yeah, it was about earphones. So what kind of earphones can I get? Which is okay. So the question actually matches retrieved context. So this is good. I can actually go ahead and run this. So I can print generate answer, which takes in the prompt that we have previously rendered. And the answer is there are several types of earphones you can get in the available products, and then it lists out the actual products. Okay, so this is what we have expected to happen. There's a lot to do in formatting this kind of answer. There's a lot to do in the context that we are actually preparing, but this is a very, very simplified version of a RAG pipeline. But before we can call it a RAG pipeline, we should first of all combine it into a single function. So what I'm going to do is add an additional section and call it combined RAG pipeline. And the combined RAG pipeline is this. So we are taking in a user's question, and then we are running all of the steps in a single function. So first of all, initializing Quadrant client, then retrieving context using our retrieve data function, then pre-processing context by running process context function, then building a prompt, and then generating the final answer by injecting this prompt into a LLM. So this is the actual RAG pipeline, which consists of 4 steps, and it just works. It's very simplified, it's very naive, but this is how it can be decomposed into several steps right here. Now we can more easily ask questions because we don't need to have intermediate steps and keep the variables in memory. We can just run a RAG pipeline and print the answer. So what kind of earphones can I get with ratings above 4.5? As an example, because we do have ratings as part of a context right here. Okay, based on the available products, you can get earphones with a rating above 4.5 with this ID, Tonaka Kids headphones, and rating is 4.5. So it's not above 4.5, but it meets the threshold. So no other item in the list actually is above 4.5, and we can actually check. So this is 4.5, and this is not earphones. And this is just a replacement of tips of earbuds. So yes, only a single item with 4.5, which is a correct answer. Now there is a lot desired in this kind of answer. For example, we shouldn't be leaking IDs right here because it might be sensitive information. But all of that needs to be taken care by prompt engineering or guardrailing this kind of answer. But in general, for this video, this is what I wanted to implement. I have a function which combines all of the steps in a simplified RAG pipeline. And in later videos, we are going to move this code into our backend application, and we are gonna move closer to productionizing our RAG pipeline. So thank you for being with me in this specific video, and hope to see you in the next one.